So today's topic is solutions. Okay. Solution in that liquid solution. So what is meant by solutions? You might have heard many types of solutions like sugar solution, salt solution. Okay. So these are regular terms. Okay. So if you consider sugar solution, so what could be the components? Components means the items which are present in a solution. Okay. So sugar and water. These are the two components that are going to be present in the sugar solution. So based on their quantity, we can define whether it is a solute or a solid. If it is a binary solution or made up of two components. Okay. If it is made up of two components, we are going to call as binary solution. Okay. So with this example, you might have got idea that solution is a combination of two components. Okay. Combination of two components. So what kind of combination? So here one is with solid phase and this is with liquid phase. But can we call if these two are in two different states? Can we are going to call it as a solution? No. If these two components coming together and mixing together, forming a liquid which is transparent or which is homogeneous, okay, which is homogeneous, then you're going to call as a sugar solution, isn't it? So what is meant by solution? A solution is a mixture of two or more components, which resulting into the homogeneous phase. Okay, homogeneous phase, or you can call the homogeneous mixture of two or more components is called solution. Okay, so here you got the two terms, solute and solvent. What is solute means, if I take this realistic example, here sugar is said to be solute and water is said to be solvent. So the solute means which is in a lower quantity or which is going to dissolve in the large quantity of other component, that is said to be solute. So as the sugar is going to dissolve in the water which is in large quantity, that's why sugar is said to be solute and water is said to be solvent. So larger quantity is the solvent and smaller quantity is the solute. Okay. So now you got the idea of solution. Okay. So solution can be made up of many different forms of the solute as well as the solvent. Okay. So whatever may be the component, it has one characteristic, that is it must be homogeneous. Okay. Solution must be homogeneous. So homogeneous mixture is said to be homogeneous mixture made up of more than one component. Okay, more than one component. It means two or more. Okay. So types of the solution. So as I mentioned in the title, liquid solution. Okay. The itself indicating it is a liquid type of solution. Okay. So the type is liquid. Okay. Now we're going to discuss deeply about the liquid solution. But before that, you must be able to know what kind of solutions are present. Okay. Means how the type is going to differ. based on the solute as well as the solvent, isn't it? So solute in sugar solution, what is solute? Sugar, which is in which form? It is in solid form. And solvent in sugar solution is water, which is in form of liquid. Okay, so if I change the phase of the solute, there can be a different solutions. Okay, so what could be the maximum existence of the phases? It is three. One is gas, one is liquid, and one is solid. Okay, so for solute there is a three phases. For the solvent also there is a three phases: gaseous form, liquid form, and solid form. Okay, so if you see the combination of these 3 and 3, it's going to be 3 into 3, 9 types. So total 9 types of solutions you're going to have. Okay, total 9 types of solution you're going to have. So what could be those 9 types? Those 9 types are, if I take gaseous phase of solute and gaseous phase of solvent, gas plus gas. Okay, so solute and solvent. So what is a gas solution or gas plus gas mixture? It is air. Air is the combination of nitrogen, oxygen and many. Okay, so it is air. So I'm still keeping the same. Okay, gas in liquid. So have you seen ever soda where carbon dioxide gas is dissolved in the water? Okay, so this is the best example of gas in liquid. Okay, and gas in solid. So you can see solid, which is a sponge. In that gas is accumulated. Okay, or you can also take palladium, platinum, adsorbed hydrogen gas. Okay, these are the examples. Okay, so in this way you're going to have 9 types. Okay, so based on the phase of the solvent and the solute. Okay, so if it is gas mixture, it is air. If it is gas liquid mixture, it is soda. If it is gas solid mixture, it is sponge. Okay, so total types of the systems of the solutions here I given. Okay, if you can see gas, solvent and gas solute, where gas is dissolved in gas. Okay, so it is air. Where liquid is dissolved in air, it is water vapor. Okay, water vapor, where vapors is in lower amount. Okay, liquid vapor is in lower amount, and air will be the higher amount. Okay, which acts as a solvent. So that's why water vapor or mist or fog is the example, best example for the liquid in gas. Okay, liquid in gas. So next, solid in gas. Solid in gas, it is soot. Okay, smoke or soot, dust. Okay, so next, gas in liquid. So gas in liquid, you can consider carbonated water, that is soda. Okay, and liquid in liquid, this you might have seen many mixtures. Okay, all emulsions and mixture of alcohol in water. Okay, all miscible liquids. Okay, what is meant by miscible? Which can dissolve in each other to give the homogeneous mixture. Okay, if you add alcohol to the water, resulting mixture will be homogeneous. There won't be any differentiation after the formation of solution. That kind of solutions are said to be immiscible liquids. Okay, immiscible means they are not going to dissolve. Okay, next, solid in liquid. So it is jelly, sorry, it is sugar solution. Okay, salt solution, whatever may be that solids, if you dissolve in water, if it is forming homogeneous mixture, that can be called as solid in liquid mixture. Okay, solid solutions. Okay, Next, gas in solid. That's what absorbed hydrogen and sponge. Okay, sponge also. Next, liquid in solid. Okay, liquid in solid. So you can take jellies also. Okay, along with this example, you can take jellies also. Okay. Next, solid in solid. These are said to be alloys. Okay, all the alloys are mixture of solids and solids. Okay, so mercury based alloys and copper gold alloy. Okay, these all are solid in solid mixtures. Okay, so this is about the introduction and types of the solutions. Okay, so in these types we are going to see liquid solutions, means the solvent is the liquid and the components may be the gas, liquid and solid. Okay, so specifically we are going to focus on this. Okay, so let's begin the core part of the liquids. Before that, you must pause all the slides, okay, all the topics, and I expect you to write better notes, as we are I'm searching from the different kinds of the notes. It is not possible to give a PDF. Okay, if at all you require, I need to make this PDF, but it would be great if you can write on your own. Okay, next, so methods of expressing concentration. Okay, so I have said sugar solution. What is meant by sugar solution? Where sugar is taken and dissolved in water. If I take 1 gram of sugar and 10 ml of water, can it be, if it is dissolved, and can it be called as a solution? Of course, it can be. If I take 10 grams and 1 liter, can it is a solution? Of course. If I take 100 grams and 1 liter, now also it can be called as a solution. Okay, but can you say sugar solution means only this or only this or only this? It's not going to work. If this sugar solution, it is having two components, that's fine, but you must express how much amount of the sugar that is present in how much amount of the water, so that then it can be specific, so that you can identify the sugar solution. Okay, what kind of the solution it is. So expressing the amounts of solvent, amounts of solute in dissolved in the given amount of solvent is said to be concentration. Okay, so concentration means the amount of solute present in the given amount of the solvent, okay, is concentration. So to express that, we have many terms that can define the concentration. Okay, so out of that, now we're going to see the 4 types. Okay, mass percentage. Okay, mass percentage. What is meant by percentage? Let's say I have 100 rupees. Okay, and in that 100 rupees, one of my friend given 10 rupees for me. Okay, if I add this, it's going to become 100. Okay, so my friend's money is 10 rupees and my money is 90 rupees. Okay, so if I consider the percentage, so my percentage will be 90. Okay, and my friend's percentage in this money is 10%. So what is meant by percentage? It is the amount or the part that is equal to the that equal in the 100. Okay, out of 100 I have 90 parts towards myself. That is what 90 percentage. Okay, So how to define the percentage? Simply, if I take 10, which is my friends, and total into 100. Whenever you are saying percentage, you must multiply with 100. So it will be 100. If I cancel, it will be 10, which is 10%. So whatever may be the percentage, you must multiply the amount of the or the part of the factor or person, okay, which you want to calculate, and to the total into 100. Okay, so if I say done with mass percentage, let's say I have taken 5 grams of sugar in 25 grams of water. Okay, as it is a mass percentage, you must take components in the grams, okay, or weight terms. Okay, so if I take mass percentage of sugar, so it is 5 grams, and the total is 25 plus 5, 30 into 100. Okay, so this will be the percentage. So how much it will be? 50, 31 gram. I think 1.6, around 16%. If I am wrong, you just calculate. This is the way, okay, that you need to perform, okay, the mass percentage. So if I want to calculate the mass percentage of the water, so you must multiply with the 25 by total into 100, okay, which is 100 minus 60. Okay, you can calculate in either of them. Okay, so next, volume percentage. So volume percentage, the method is same. Okay, if it is volume percentage, if it is mass percentage, method is same. Let's say I have taken 2 ml of lemon syrup, okay, lemon juice, in 10 ml, dissolved in 10 ml of water. So the solution will be with total 12 ml. Okay, so volume of the, let's say, solute, okay, volume of the solute is 2 ml, and total volume will be 12 ml. Okay, so the percentage will be into 100. Okay, it is 6. So I think it is also 16% around. Okay, so if it is volume, it is the ratio of volume percentage. Okay, if it is mass, it is the ratio of mass percentage. Okay, total mass you can into 100. Okay, so very simple terms. You must able to know the percentage calculation. That's it. If it is mass, mass percentage. If it is volume, volume percentage. The next is mass fraction. Okay, mass fraction. The mass fraction, wherever the term fraction means, if I take you are going to understand very well with the pie chart. Okay, so let's say this is 25, okay, and total is 75. Fraction means if I take fraction of a in total, okay, in total, so it is the part that is going to acquire, okay, part. So part of a is 25, okay, part of a is 25. Out of this is total will be 100. Okay, so total will be 100, so it is 1 by 4. So the fraction of A is 1/4. Okay, where the fraction means it is a ratio. Okay, ratio. So fraction of A will be 1/4. Fraction of B will be 75/100. It is 3/4. Okay. In the same way, we are going to calculate the mass fraction. Okay. So mass fraction. Third expression is mass fraction. So mass fraction means, let's say in earlier example I have taken 5 grams of sugar and 25 grams of water. Okay, let's say 20 grams of water. Okay, so mass fraction of sugar, okay, mass fraction of sugar is 5/25. Okay, so it is 1/5. Okay, 1/5 part of 1/5 fraction of the total is occupied by the sugar. Okay, 1/5 fraction of the total mass is occupied by the sugar. Okay, in the same way, if I take mass fraction of water, it is 20/25. So 4/5. So 4/5 fraction occupied of the mass occupied by the water. Okay, this is what mass fraction. Okay, so mass percentage, volume percentage, and mass fraction. If I consider volume fraction, so in the same way, so volume fraction. Okay, so for the same example, 2 ml/10 ml. So volume fraction of lemon juice. Okay, lemon juice. So it is 2/12. So 1/6 fraction of the total volume is occupied by the lemon juice. Okay, and 10/12, which is what volume fraction of the water. This 10 by, so 5/6 fraction will be with the volume of the water. Okay, so if you add these two, 1/6 plus 5/6, okay, it will be always equal to 1. Okay, same. If you add the percentages of the all components, it will be equal to 100. Okay, if you add all the fractions of the components, it will be equal to 1. Okay, that you must remember. So this is about the brief methods that you are going to see in concentration expressions of the liquid solution. Okay, in the next class we are going to see the actual terms that are very important for the expression of the compound. Okay, so I hope you understand. If not, or if you have any doubt, or if you want to discuss, let's come to the WhatsApp group, or you can directly call me and you can ask for your doubts. Okay, thank you.